Good morning. My name is Han Yang. I'm the product manager for the Cisco Nexus 1000V. Thank you for coming. Thank you for joining us on 9 o'clock on a Wednesday morning. So we actually introduced the Cisco Nexus 1000V back in VMworld 2008, where we were fortunate enough to win the Best of VMworld. Right? And since that time, we actually shipped the product back in May of 2009, along with VMware vSphere 4.0. We actually, prior to shipping the product, this product actually went through the largest Cisco switching and routing beta ever. The only thing that has a bigger beta at Cisco is actually WebEx. Right? We had participants from 39 countries around the globe. Something like 1,300 participants helped us out with our beta program. By now, we actually have customers who have downloaded our eval from over 130 countries around the globe. We're pushing the limits of what United Nations is in terms of member capacity, right? We have over 1,000 customers. I think that number is actually quite low by now. We actually have a lot more than that. Earlier this year, we shipped the Nexus 1010. This is actually our physical appliance hosting the Nexus 1000V virtual supervisor module, along with other virtual service blades. And at this point, I'm very happy to report that we have shipped over 1 million virtual Ethernet ports. Right? At Cisco, reaching the 1 million port mark is a significant milestone for us, but I think it's a much bigger milestone for all of our customers that are able to leverage the Nexus 1000V in their production environment so that they're in a position to treat virtual machines as a basic building block of the data center. Right? No different than their physical servers. I think at the end of the day, regardless of what our port counts, it's those kind of customer satisfaction that brings warmth into my heart, right? Earlier this week, on Monday, we had a session with customer panels where we had, Certa Health, Fujitsu, SunGard, and even Cisco IT was on stage describing how they're using the Nexus 1000V in their production data centers. Right? And feel free to go check out some of the slides that you'll find on VMworld because they actually showed their topology, how they're hooking up Nexus 1000V with the upstream physical switches, and how the complete topology works out in their particular environment. Right? We've literally gone through lots and lots of deployments, and we're very happy with the results. The Cisco Nexus 1000V, our basic mission is to simply make sure that you are in a position to have treating the virtual machines as a basic building block of the data center, right? We actually started this project something like over 4 years ago. And the reason that we did this is because, well, we're not just a vendor. We're also a customer, right? Like I mentioned earlier, Cisco IT is actually a very large VMware shop. When our customers come in, we typically, customers ask, right? How does Cisco IT use the products that Cisco makes? And hence, we actually have a term called Cisco on Cisco, describing precisely how Cisco IT leverages the various Cisco products. And this problem came about when we actually talked to Cisco IT and saying that, how does the network team gain visibility down to the virtual machine level, especially with vMotion taking place, moving from one server to another? Right? And hence, when we came up with the Nexus 1000V, we had 3 specific properties, right? We wanted to make sure that the network team and the server team are able to have what we call policy-based VM connectivity. So you're able to describe the network policy once in a cookie-cutter fashion, and then to be able to apply that to the production of virtual machines. And with that policy, you'll follow the VM wherever it goes, including vMotion, right? Whether it's network statistics, whether it's network configuration, or even when that particular VM is participating in monitoring sessions like port mirroring or network statistics gathering, vMotion shouldn't matter. You should still be able to monitor the VMs wherever it goes. And that's exactly what we achieved with the Nexus 1000V. And finally, with Nexus 1000V, you have something called the non-disruptive operational model. What does that mean? It's marketing buzzword for saying that, hey, the network guy and the server virtualization guy gets to use the same tool that you've been always accustomed to. But at the same time, making sure that you have a consistent view of your virtualized data center, may it be from VMware vCenter server or with Cisco tools with like command line interface, SNMP, and so on, right? Making sure that both the network team and the server virtualization team are able to get their jobs done, leveraging the expertise that they've developed, leveraging the certification that they have. That's what we're trying to achieve with the Nexus 1000V. So as you virtualize, virtualization shouldn't be treated as a special case. You should be able to treat virtual and physical infrastructure in exactly the same way, helping you to scale. Helping you to scale server virtualization. And after all, that's precisely why Cisco and VMware have been partnering for so long. Okay. Just to level set, this is the architecture of the Nexus 1000V. Nexus 1000V has two major parts. Let me try this laser here. The first is what we call the virtual supervisor module. This is actually an instance of NXOS that's tightly integrated with VMware's vCenter server. Okay, what does that mean? That means that, well, the network now knows about vMotion when it takes place because we get it directly from vCenter server. The second component is what we call the virtual Ethernet module. This is a piece of Cisco software running in the kernel of the VMware hypervisor, providing the switch ports for all of the virtual machines. Right? A pair of active standby supervisor modules here is actually able to support over 2,000 virtual Ethernet ports. Right? If you're familiar with Cisco modular switching architecture, what I've just described is a virtual modular switch, where you can have up to 64 virtual Ethernet modules, or 64 ESX hosts, all being managed by a pair of active standby virtual supervisor modules. And this is what we've built. We literally took the code from our larger modular switch called Nexus 7000 that has all these capabilities. We integrated with VMware vCenter server, developed a software line card called Virtual Ethernet Module, and voila. That's how we built the Nexus 1000V. Right? So it's able to leverage all of the networking expertise from literally years of switching development, but optimized in a virtualization environment, giving both network administrators and server virtualization administrators the ability to monitor your virtual machines. Ever since Cisco introduced the Nexus 1000V as a layer 2 switch, customers have been asking, so Han, when are you going to do something about layer 3 and 4, right? With Nexus 1000V, you already have the network team able to work in a collaborative fashion with the server virtualization team. What are you going to do about layer 4 through 7 services, right? In fact, yesterday we started at Ed Bugnon's keynote, we started talking about exactly that. What Cisco is doing about network services in a virtualized environment. And I'll be going through that in a little more detail today. Again, our idea is that, well, not only should the network team and the server virtualization team are able to work together, now we're extending it to even security administrators as well. Right? Let's go into that in a little more detail. Cisco clearly ships a lot of level 4 through 7 services modules today in the form factor of physical appliances or service modules, you name it. And our customers are continuing to ask us to virtualize them. Right? And hence we're introducing a concept called virtual service nodes, the ability to virtualize a lot of these capabilities in a generic fashion. And hence Cisco is actually developing architecture to support all of these services in a virtualized way, in an architectural, systematic way, right? Instead of just having a virtual appliance for every one of your network services, let's make sure that we have a consistent architecture that can help you scale in terms of these network services, scale in terms of capacity, scale in terms of multi-tenancy, right? Making sure that you are paving the road into the cloud, right? This year's VMworld, as you see up here, virtual roads, actual clouds. Well, Cisco would like to help you pave those roads, right? Making sure that you're able to get to the cloud in a systematic fashion. Now, if you look at the network topology today, from a virtual machine, you can clearly pipe the traffic out to get network services from the physical appliances or service modules, right? And you need to do a bit of traffic engineering to pull that off, but that's exactly what some of our customers are doing today. And they also ask, like, so when is Cisco going to do something like a virtualized service node where you can put these services perhaps immediately into the hypervisor so you can do these type of services exactly where they're needed without having to pipe that traffic out and sending it right back in. Right? And in fact, we've been talking to a lot of customers and we've been trying to find out exactly what are the requirements. Right? The first one is, of course, it's easy. You got to virtualize, right? You got to virtualize from a physical form factor into a virtual machine. Okay? We got that message, right? The next one is like, well, don't just scale up. Help us to scale out, right? Let's say if you have a 10 gigabit firewall. Well, if you run out of capacity, you can buy another one, but you may not use all of that 10 gig capacity on day one. Is it possible to scale out and add incremental firewall bandwidth over time, right, as I need them? Right? And customers also made it clear to us, you need to have kernel-level acceleration, right? Having network services as a guest VM implies significant performance penalties. If you can do more things in the kernel, it means that you get better performance on the hypervisor systems. Customers also tell us that you have to work on the context, right? Firewalls have context, but can you help us to scale out in a multi-tenant fashion so that you can support lots and lots of customers at the same time on a common physical infrastructure, right? And finally, customers tell us that you got to have a flexible deployment model, right? Making sure that you're able to leverage the virtual service nodes possibly in different hosts, right? Because if you have to have a virtual service VM on every single hypervisor, then you're wondering, like, did I buy the servers to run my production VMs, or did I buy them to run network services? Right? And depending on who's paying, you might have a very different answer on how that agreeable those decisions have to be. And hence, by having a more flexible deployment model, you can have some of those budgetary warfares lightened up a little bit, right? So these are the things that we've been hearing from customers, and we want to have a comprehensive architecture that is capable of supporting all of these requirements in a systematic fashion. Now, we already started down this path, right? In fact, last year at this VMworld, we introduced a feature called virtual service domains. This is a capability to provide, to group, right, virtual machines in a logical fashion so that they enjoy consistent networking policy. Right? In this case here, I have, let's say, the blue VMs, maybe they're engineering VMs, right? And the green VMs, perhaps they belong to finance or something, right? If the engineers need to talk to themselves, the traffic goes unfettered, right? But if the engineer needs to talk to a finance person, we force that traffic through a firewall. And that traffic is forced through the firewall not by fancy traffic engineering, rather by merely stating the fact that as part of the policy, this needs to occur. Nexus 1000 is smart enough to take advantage of that, right, and force the traffic through the firewall VM. In this case, the firewall VM can be any layer 4 through 7 services VM. Populated on every single server, Nexus 1000 will force the traffic, forcing this type of topology, including vMotion and so on. That's why we show 2 servers here. But one issue is that the network service is being applied as a guest VM, and hence there are some performance penalties associated with that. Right? But even last year, we started to make sure that you want to be able to specify the service policy, in this case, the security policy, from a policy grouping perspective, right? So you don't have to do fancy traffic engineering just to make sure that all the traffic are forced through that firewall. So this year, we're introducing a new architecture. We're introducing a new architecture built on top of the Nexus 1000V, what we call Cisco vPath. Right? Cisco vPath, there are several attributes. The first one is what we call intelligent traffic steering. Right? In this case, I'm showing traffic coming outside the server. The traffic could have come from a VM as well, but just for illustrative purposes. The traffic comes in, and we realize that, this particular destination VM has a security firewall policy. Right? And so we'll redirect it to what we call a virtual service node, a service VM possibly on a different host. And that decision, whether to send on or filter that traffic, is sent back to the virtual Ethernet module with vPath, and we actually cache that flow entry. Right? So now the virtual Ethernet module remembers that. The virtual service, though, says it's okay to send the traffic on, right? And hence delivering the packet to the destination VM. So now the virtual Ethernet module knows something about this particular flow. The second aspect of vPath is that there's a flexible deployment model. Okay? You'll note that production VMs can be separated from your virtual service nodes. right, from the servers hosting these VSNs. Right? So now you can have the servers that are dedicated for production virtual machines, and another set of servers dedicated for virtual services. Right? You can mix them and match them as if you so desire, but just in case you wanted to separate them, you have that flexibility. The second thing to note is that you notice that one virtual service node is actually able to serve multiple physical servers that need that particular network service. Right? So you don't have to have a virtual service node on every single physical host. So now you're scaling your virtual network services not based on how many hypervisors you happen to have. Rather, you're scaling it based on how much firewall bandwidth do you need, or how many load balancer bandwidth do you need, and so on and so forth. Right? You're scaling it based on your particular application and traffic patterns. Right? The third aspect about vPath is performance acceleration. Right? Notice that the vPath is able to cache the decisions made by the virtual service node inside the virtual Ethernet module. So we're actually reducing the amount of traffic steering. Right? So it's not like every packet that comes in is redirected to the virtual service node for inspection. Rather, only the first few packets are redirected, and once the decision has been made, the virtual Ethernet module is able to cache it, and so future packets in that flow is immediately executed based on the policy inside the virtual Ethernet module and sending it on to the virtual machines. Okay? And notice that all of this is happening in the virtual Ethernet module, which is in the kernel of the hypervisor, giving you that performance acceleration. Right? If you're familiar with physical firewalls, for example, there are these slow path and fast path. Right? We've taken the same concepts, apply them in a virtualization fashion. Similar how we have done with the Nexus 1000 from a switching perspective, we're extending that same knowledge and expertise, again, for services in a systematic fashion, in an architectural way, applying it to the Nexus 1000V. In fact, the very first virtual service node leveraging the vPath architecture is the Cisco Virtual Security Gateway. It is a firewall that's helping you to make sure that you can have trusted segmentation, leveraging the same common servers and VLANs in a multi-tenant fashion, supporting lots and lots of different logically isolated applications. You're able to have dynamic operation. Clearly, this architecture needs to support vMotions, VM bouncing back and forth with DRS turned on. And finally, we're extending, right? We're extending the operational model from the network person to the server virtualization person, and now there's a new member on the team, the security admin, right? Making sure that all three of them have the same logical, consistent view of what's going on in the virtualized data center, helping you to leverage vSphere, leverage your virtualization infrastructure that much more in a secure fashion. In fact, this diagram shows that different zones are set up on a common set of compute infrastructure and even on a common set of VLANs behind that. At the same time, having them to be logically isolated among all three of these particular zones. This diagram just simply showing that even when new VMs are brought up, requiring the same security policy, the zones are now logically extended across two servers. Right? vMotion actually continues to work, protecting the policy. Right? You may ask, like, so with all this traffic steering and redirection, how do you make sure that the VM migrating from one server to the next continues to enjoy the same security policy as dictated by the firewall? Actually, it's relatively easy, right? When the VM migrates to the new server, the new destination server, the virtual Ethernet module is going to say, I have a cache miss, right? I don't have an entry for a traffic pattern coming to this VM, right? I do need to query the virtual service node yet again for first few packets, and then I have a entry in my flow table so that future packets are now going to be cached in the virtual Ethernet module on the right, helping you to make sure that future packets continue to have that performance acceleration, and thereby making sure that the network security policies are also being transferred from one physical server to another. And with this now, you have that type of dynamic operation capable of supporting vMotion and making sure that you continue to have high availability. Right? Notice that this diagram has an active and a standby virtual security gateway. Right? So if one server goes down, that doesn't mean that your security policy takes a momentary lapse. Rather, the standby virtual security gateway takes over, making sure that you continue to enjoy security, right? Because security is not just something that's nice to have every moment of every day, especially 2 o'clock in the morning. This needs to be there, okay? Helping you to have a secure, robust, virtualized environment. So now with it, it's like, most traditional firewalls, they look at IP addresses, MAC addresses, right? And in fact, the Nexus 1000V architecture has a virtual supervisor module talking to all the virtual Ethernet modules. To manage the virtual security gateway, Cisco is introducing a new piece called the Virtual Network Management Center, VNMC, that's talking to both of them. And this is a piece, this is the admin tool for the security admin, so they're able to set the security policies. But historically, firewalls, for example, you only know the MAC and IP address, right? And you got to make a decision based on that, right? And if you're truly a security guy, then you'll know there's things like IEEE 802.1x that authenticates particular VMs and so on to give you additional information about who's talking, right? Who is this MAC and IP address that's talking? And hence, I can make better decisions about whether to make this packet go through or not. But in a virtualized environment, you can actually query the VMware vCenter server to know, hey, I actually know more about this who's talking because I can ask, what exactly is the VM that's in question, right? I know that the name of the host, the name of the VM in question. Which VDC does it belong to? Is it Linux or Windows? I can find out about all these things and make sure that these attributes are also part of my firewall policy. And hence, I can more intelligently filter and specify the security policy, not just on the MAC and IP address. I know more about who's talking because I can find out what VM is actually sending the traffic. And with it now, you have the ability, you don't have to do any fancy traffic engineering to force your traffic through a firewall. By merely specifying it as part of the policy, all of it goes to the virtual security gateway via the vPath architecture. Okay. As I mentioned before, everything is virtualization aware with vMotion working. Okay. And now you have a complete picture where you're managing multiple independent zones on a common set of physical infrastructures, making sure the network team, the server virtualization team, and the security team now are able to consistently see what's going on in your virtualized data center, giving you this picture, right? So now you have a policy-driven data center for your networking policy and your security policy. It's fully mobile aware in terms of vMotion, and at the end of the day, I've shared this with all my customers before. The very first time that I actually found out what DRS is all about, right, with VMs being migrated on an automated fashion, right, I'm trying to ponder that in my head, right, and I go home and I have 2 kids, young kids running around, dragging their toys around the house, right? So the first thing I thought of was like, it's 10 o'clock at night. Thank goodness I know where my kids are. But with DRS, do you know where your virtual machines are? Right? With tools that we're building from a Nexus 1000V and now with the virtual security gateway, you're in a position to know exactly where they are with the right policy configured and the robustness to make sure that what you specified, what you've set up, is consistently following the VMs wherever they are. Okay, so thank goodness my wife watches my kids very well. Now you get to have virtual leashes on your VMs. Right? In a multi-tenant fashion, no less. Right? So a lot of customers have been asking me, like, hey, VMware introduced vSphere 4.1 back in July. Steve Herr, in his general session yesterday, mentioned a lot of the capabilities. I just wanted to highlight 2 of them here. With vSphere 4.1, there's that ability to classify traffic going out from the ESX host onto the upstream physical NICs. In fact, they're able to classify from a vMotion, iSCSI traffic, fault tolerance perspective. we take it a little bit one step further, right? You're actually able to set up differentiated SLAs for your production VMs, right? In fact, we call this feature weighted fair queuing. And in fact, we do this across what we call a port channel, or multiple network interface card treated as a single logical channel, right? In this example here, I have the yellow VM taking up 75% of the overall bandwidth on 2 physical network interface cards, right? And the blue VM able to take up 25% of the aggregate bandwidth, right? And in fact, we actually dynamically adjust the amount of bandwidth on a per link basis, making sure that the overall port channel across both of them reflect the minimum bandwidth that you have set for the VMs, right? So what does that all mean? That means that in your cloud, may it be private or public, you're making sure that these VMs get the bandwidth that they need, right? Making sure that they get to have a much more finer grained policy when it comes to bandwidth, especially at 2 o'clock in the morning, right? And we also added the ability to have something called ER span, which is basically port mirroring, but there is supposed to be specified on a policy basis as part of the port profile. So it's like, customer has like, well, okay, so Nexus 1000 had ER span before, so now you just specified it on, instead of on a per port basis, you're specifying on a port profile basis. Okay, that's pretty incremental advancement, isn't it? It's like, yeah, that's true. But you know what? This is actually becoming a critical feature. Why? Because now you're able to specify as part of your policy whether you want to mirror traffic for all the ports that's using a particular policy. So when you have a virtual data center, especially as part of the VMware vCloud Director, right, all the ports using a particular profile is now mirrored, helping you to troubleshoot and diagnose what's happening on a particular VDC, right? Because now you have this multi-tenant environment with lots of VMs, right? That's what we're trying to achieve, right? We're trying to achieve a higher level of efficiency by having all these multi-tenant virtual machines on a single set of common physical infrastructure. But if one of those VDCs goes wrong, and invariably they do, how do you know? How do you make sure that all these multi-tenant environments, you're able to filter out just the one particular VDC, figure out what's going on with that, without exposing all the traffic for all the other VDCs possibly belonging to different tenants, right? Because if you just share the pipe of traffic with everything that's going in and out of your servers and sharing that with all of your customers, I bet none of those customers will be very happy because you're letting other customers see other customers' traffic, right? From a multi-tenant perspective, that's probably not the best way to troubleshoot. This type of feature allows you to hone in on a policy basis into very finely granular fashion down to the particular VDC in question and help you troubleshoot. Right? In fact, this is just one animation helping you that you can specify a particular policy, in this case the blue one, to be able to pipe it out to either intrusion detection or firewall or simply monitoring tools to help you figure out what's going on. Right? This type of capability fits right in with the VMware vCloud Director that was announced yesterday. Nexus 1000 supports all of the types of networks supported in the vCloud Director. I'm still much more accustomed to referring to it as Redwood, as Steve Herod was doing yesterday as well. There are also multiple types of network isolation as part of the VMware vCloud Director. There's VLAN back, there's those that are based on VLANs, and there's also the vCloud network isolation. Right? We're working very closely with VMware to ensure that both Cisco and VMware are able to fully support and interoperate in this type of cloud environment. Nexus 1000V, working with the VMware vCloud Director, is actually being shown at the Cisco booth. Right? So if you want to take a closer look, feel free to stop by. Right? And Nexus 1000V, right, when vMotion first came out, requiring layer 2 adjacency, everybody's like, when are you going to cross layer 3 boundaries? Right? When can I do long-distance vMotion, right? This slide is just one example of many that Cisco has been working very closely with VMware and other partners in terms of extending the vMotion range, in this case between data centers with a technology called over-the-top virtualization, or OTV, right? Helping you to gain additional flexibility so that you can migrate your workload from practically anywhere, helping you to pave the way, paving the road into the cloud. Okay. There's a lot of questions these days with new standards in the IEEE, and a lot of customers get asked, like, what are all these standards mean, and what do they do, and is Cisco complying to all these standards? Well, the answer is actually pretty simple, right? The answer is yes, right? In IEEE parlance, Nexus 1000V is a virtual Ethernet bridge, right? We simply happen to be a fully featured virtual Ethernet bridge with access control list, quality of service, and so on, right? We have all the features that a production data center class switch needs, except they're all being applied at the virtual machine level. Right? All these other hardware, all these other standards are being applied to the upstream physical switches, allowing you to leverage the upstream physical switch for virtual machine traffic switching. And Cisco already supports a lot of these already. Right? From a Cisco perspective, the technology we've been talking about is what we call VMlink, which is adding server virtualization intelligence into the network so that I can understand vMotion. Right? We actually have two implementations today. One on the Nexus 1000V from a software perspective, giving you a lot of scalability and strong feature richness. Right? As a software switch, right, we can actually introduce features a lot faster than hardware. Right? But the hardware offloading is also very important. As you continue to virtualize more, the performance of your virtual machines is very important, and hence that's why Cisco introduces on the UCS and other platforms much higher I/O performance for your virtual machines, right? And the hardware VMlink and the software VMlink are both being shown in a Cisco booth, right? From a performance perspective, from a flexibility and scalability perspective, right? Software and hardware, and that's why Cisco is providing both solutions to help you address your virtual machine needs, right? Depending on your particular deployments and requirements, we're offering a full suite of solutions to help you out. Now, at the beginning of this presentation, I pointed out that we shipped a product in May of 2009, along with vSphere 4.0. And over this past, has it been 15 months yet, right? Roughly. We've actually introduced a lot of new versions and features along the way. And sometimes the customers get a little bit confused, right? Because we actually changed some of our best practices. So I have a little quiz for you, right? Is Nexus 1000 based on proprietary switching technology? Can I see a show of hands? Do you think that's the case? Well, good. I see I have a very enlightened audience here, right? In fact, because the Nexus 1000V is fully based on the IEEE standard 802.1q, right? That's the standard that defines Ethernet switching. That's exactly the one that we've been building to and implementing, because guess what? It comes from a long history and heritage of Cisco physical switches simply being applied on a virtual setting. Right? This one we're getting down to more nitty-gritties, right? Does Nexus 1000 only work with Nexus switches? Raise your hand if you think it's yes. Wow. You guys are enlightened, right? Actually, as part of the standards, we work with almost any switch, right? We work very hard to make sure that we continue to adhere to the IEEE standards. Right? Should the VSM be placed on the VEM? Should the VSM be managing its own data path? Is that a good thing to do? Is that a bad thing to do? Any thoughts? Yay, nay? Okay. We do actually recommend that. We actually help you have instructions on how you troubleshoot that when you get in trouble. Right? Some of the other customer panels, we had a customer panel from Cisco on Monday, but there was actually another session from talking about the Nexus 1000V from a channel partner. And they also tried various different things. So you can also check those sessions out in terms of what they think about having the VSM on the VM. Right? And can the VSM be vMotion? Yes? Did I say it? Definitely yes? Yeah? Yeah, you can. Right? We actually don't recommend DRS quite yet. We had some customers that got in trouble, right? Because VSM is a supervisor, and if you lose that, other things can happen, right? Traffic will continue to flow even if the active and standby VSM is disconnected from the virtual Ethernet modules. But when you lose the supervisor, right, it's never a good thing. So we're being a little bit conservative on that front. Right? So in short, we've had an awesome ride in terms of Nexus 1000V, right? Our customer adoption has been extremely strong. Our biggest challenge is making sure that Cisco continue to scale effectively, right? We've introduced vPath so that it's able to be able to scale network services across the breadth of services. We introduced Cisco Virtual Security Gateway as a firewall feature. That's the first one to leverage the vPath. You can actually have differentiated SLA. That's part of the with vSphere 4.1, and we're working very closely with VMware. It's supporting VMware vCloud Director today. We'll continue to enhance that to make that even better. Right? Stop by booth 801 for Nexus 1000V demos. And I also wanted to point out, if you go to the Moscone West, is it lab 29? 29. There's actually a Nexus 1000V lab as well, right? Where you can get your hands-on experience working with this technology. Thank you.